Welcome to a fireside chat on technology innovations driving the future of autonomous vehicles with a specific role on AI. First, I would like to provide some context around the chat, and then I will introduce our guest speaker for today, Wei Luo from Nvidia. And of course, we'll be taking audience question. Slido.com, the code is Easton2. So let's jump right in. We live in fascinating times. In autonomous vehicles, which holds immense power and possibilities for disruptive innovation, as well as improving accessibility, lowering the cost, and creating improved outcomes in critical areas of transportation. If we take a look at AI revolution, the global autonomous vehicle market has grown from $50 billion to $500 billion in the last 5 years alone. And the growth is driven by the potential to completely free up drivers to perform other tasks. It's estimated that productivity gains could add up to $1 trillion in the US economy alone. And last year, autonomous vehicles drove more than 9 million miles in California, showcasing rapid progress in real-world testing. And these test miles are crucial because they expose AVs to a wide range of real-world scenarios, helping to improve the decision-making algorithms and safety features. Companies like Waymo have begun commercial operations in major cities, with over 150,000 people waitlisted in Los Angeles. If we talk about AI's role in autonomous vehicle development, it's the key underlying technology enabling areas like perception, decision-making, and control systems. Deep learning algorithms are enabling vehicles to understand complex environments and make split-second decisions. For example, these algorithms can distinguish between pedestrians, cyclists, other vehicles, even predict their movements, and adjust vehicles' path accordingly. Nvidia's role in providing powerful computation platform for AV development has been instrumental in advancing the field. Their GPU-accelerated computing has enabled real-time processing of vast amount of sensor data, and Drive platform provides a comprehensive solution for AV developers, from simulating and training to in-vehicle AI computing. As with all fields, challenges remain. Technical hurdles in areas like handling edge cases and achieving human-level perception in all weather conditions. Edge cases are rare, but critical scenarios that AVs might encounter, such as someone running onto the street or navigating through a complex construction zone. Regulatory frameworks are still evolving, with different approaches across states and countries. And these range from strict regulations requiring human driver in every car to moderate approaches that require AVs to show they can perform than average human beings. The potential impact on jobs, urban planning, and personal mobility is significant and requires careful consideration. For instance, AV technology might displace some jobs, but it will also create some jobs in other fields, such as AV maintenance, fleet management, and passenger services. Urban planners may need to rethink parking structures and road designs to accommodate AV fleets. And if we take a look at California's leadership, California hosts the highest concentration of AV companies in the world. Our state has been proactive in creating regulatory frameworks for AV testing and deployment, and there's a delicate balance between fostering innovation and ensuring public safety. And the purpose of today's panel is to explore the current state of AV technology, AI's role on transforming the transportation industry, future vision, and some of the use cases. As we begin to discuss these large-scale technological innovations, I cannot think of a better speaker than Wei Luo from Nvidia. So please welcome Wei Luo. Wait, so good to have you here.
Yeah, thanks for having me.
So let's start with a brief introduction, and then we'll jump right into questions. Wei Luo is the Vice President of Autonomous Vehicles at Nvidia, where she leads the company's efforts in developing cutting-edge AI and computing solutions for the automotive industry. With her extensive experience in autonomous systems and deep learning, she has been instrumental in advancing AI's position as a key player in the AV ecosystem. And prior to joining Nvidia in March this year, Wei served as the VP of Product Strategy and Operations at Cruise, where she was responsible for shaping the company's strategic direction, overseeing the technical product roadmap. Her ability to navigate complex intersection of technology, strategy, and operations was instrumental in driving Cruise's progress in competitive AV landscape. And before her tenure at Cruise, Wei was also the Chief Operations Officer and the Head of Product at DeepMap from 2016 to 2015, which was eventually acquired by Nvidia. She was a part of founding team that built DeepMap ground up, transforming it into a leading provider of the high-definition mapping solutions for autonomous vehicles. And her leadership was crucial in developing cutting-edge technology that addressed some of the most significant challenges in AV development, such as precise real-time mapping and localization. Wei holds a PhD in Geographic Information Systems and Remote Sensing from UC Berkeley, where her research was focused on advanced mapping technologies, and she has a dual degree in urban planning and economics from Peking University. And Wei, so great to have you here today. Before we get into the discussion, I just want to congratulate the Easton Center for Technology Management, so Professor Kramer, Heather, Darina, and all the volunteers here today, and the incredible Andertech team. What a great job you guys have done organizing the attendance, whole thing. We have a record attendance here today, so thank you so much.
Yeah, thanks everyone.
So if we talk about the current state of AV technology, can you give us an overview of where we stand today with autonomous vehicle technology? What are some of the most significant recent breakthroughs, and what challenges remain?
All right, so first of all, I think like autonomous technology should not be foreign to group of people here, right? Like Waymo actually operates autonomous vehicles in parts of LA. So I hope many of you have taken a ride and like it. And a lot of these self-driving or a full autonomous robotaxi are being rolled out in not only LA, but San Francisco has Waymo presence, Cruise presence. And in different parts of the world, we also have seen AV technology being applied not only to robotaxi, but to other different sectors of industrial setting. For instance, in China, there is a fully autonomous port being operated by autonomous vehicles where there is no actually human involved and the goods are being transported entirely autonomously. And then there are actually very cute applications, in my opinion, street sweeping cars that comes out at night and clean the streets and then so on. So in my observation, a lot of these AV technologies are not only being applied to consumer market, industrial market, but then also very specialized environment as well. This is a gradual process. Obviously, safety is the most important thing that we need to be mindful of, whether or not the vehicles are operating on public roads versus in specialized industrial setting. Safety is always the most important thing. And then going back to the question, like what are kind of the innovations and challenges? Again, I think to this very technical and knowledgeable audience here, it's probably no surprise that very recent technology innovations like large language model or the philosophy of large language model or AI-based foundation models is being applied to advanced self-driving technology as well. And I can talk more about that later on. And challenges, as I mentioned, safety is always the hardest thing. We want to see the technology being rolled out in a safe, gradual manner. And then the goal is always not only to meet human driving benchmark, but be many times better and safer.
Awesome. What's your perspective on the widespread AV adoption? Say a bit more about the market trends, the shift in consumer demand, and the use cases. What does success look like in this field? Mm-hmm. And drive one level deeper on this.
Sure. So like I mentioned, like the AV technology is not only being applied to consumer market, it's being used in a lot of industrial settings as well. Robotaxi is obviously the most well-known one, but people may or may not be aware the similar type of AV technology is being rolled out in consumer markets for passenger cars as well. I mean, actually, like this shouldn't be a surprise. Like Tesla is one of the great examples of that. And there are many OEMs in China doing very similar things, having great performance for consumer cars as well. And I mentioned, autonomous vehicle or autonomous technology being used in industrial settings like ports and factories and whatnot. Another great example of where this technology is really useful is actually logistics. So long-haul trucking, last mile delivery, or deliveries from what we call the regional distribution center to local stores. Like for instance, you can have a Walmart regional distribution center, and then maybe 50 miles away you actually have a local Walmart store. And then these type of last mile delivery for commercial usage is another great application of this AV technology as well.
Interesting. So go through in more detail because it's always an interesting exercise in autonomous vehicles. People keep saying that self-driving cars and flying cars are the future, blah, blah, blah. The issue is always interesting. Generally, technology-based innovation happens. The variable issue is how quickly it happens. So our ability to say it's a couple of years from now versus 20 years from now, it matters. So if we look at the enablers, what are some of the things that have to kind of line up to say, these things are going to be now, what would they be? Quantity and quality of data, commingling of fleets, shift in consumer demand, unit economics could be the key driver for commercialization. What are some of the other things?
Yeah. So in terms of enablers, so first of all, I keep mentioning safety because I really truly believe that is the most important gate for the technology to be rolled out in a widespread fashion. But in order to enable safety, the technology needs to be there. A lot of things that enable safety includes tons of data, like for us to actually both train the models that we apply in the AV technology stack development, but then also for us to actually validate whether or not our technology is safe or not. Because when we rolled out, let's say, either a next iteration of a technology or when we're doing just regular software updates, the very first thing we got to do is to actually validate and then check all the corner cases to make sure we're not making any mistake or overlooking certain corner cases. So data, or high quality data in large quantity that can cover a diverse range of environment is extremely important. But then moving away from or in addition to the technology enablers, I think regulatory environment is actually very important as well. Typically, European governments have more strict and more standardization that are applied to just car development in general. US, generally speaking, is less strict or less prescriptive. But then if you look at the entire world, obviously there is Asian markets as well. There is not enough, I should say, consistency in the regulatory environment in terms of how to regulate what AV technology needs to do. And that actually poses certain challenges for companies like Nvidia who are into developing AV technology to serve all the markets. So that's another thing that I really wish that we could do better as well.
Awesome. Yeah. Let me ask you another macro question here. So when we talk about AI's role in transforming transportation, how is AI fundamentally changing the approach to vehicle design and operations? What excites you most about the potential of AI in transportation?
Oh, wow. So for people who are following the news of AV technology, I think you will see a pretty big change in the past a year or so, or a year and a half to no more than 2 years, which actually very much coincide with the revolution of the GPT chatbots and revolution of LLM and so on. And this is because in the past 2 years or so, AV technology or AV stack actually have gone through or is going through a very similar transition that people see in the LLM or chatbot world. Previously, a lot of these AV technologies have been developed with what we call heuristic or rule-based technology, which is very much mimicking what you need to do when you take a driver license exam, right? Like you gotta stop before a red light, you gotta yield to traffic when you see a yield sign, these type of things, which is great. It actually carried a lot of companies or technology to the point where we see today. But the introduction of AI actually takes a very different perspective, right? It builds foundational model based on a lot of data, and it's actually mimicking how humans are reacting to different ways of traffic condition. And this allows the AV stack to be a lot more flexible. So rather than following strict rules, which almost are impossible to iterate given how much diversity we see on the road and different traffic or driving behaviors from different cities and whatnot. And by the way, I got my first taste yesterday when I was coming from airport to here. I was like, oh, it's like a roller coaster ride with my taxi driver, right? So, and these type of like changing driving conditions or driving behaviors will be very hard to tackle with the traditional model, but this is where the AI model can shine because it can be more flexible and adapt to different, driving environment and behaviors.
Interesting. And how is Nvidia addressing concerns about black box nature of some of the AI systems? And for members of the audience here, the term black box in AI refers to a system where internal workings are not easily understood or interpretable, even by the companies or their creators. The lack of transparency can raise concerns about reliability, safety, and accountability in critical applications like autonomous vehicles.
Yeah, so this is an excellent question. Again, for people who have an interest or have been following a little bit of the news or technology development in AV, or in general, the general field of AI, you probably have heard this safety concern about AI system quite a bit. Because end-to-end models or AI models are considered as black box. You give it some input, it tells you something in return. You have no idea what actually happened in between, right? But one thing I want to maybe first call out is that, in my humble opinion, at least, I don't think we should equate black box to something unsafe. Right? Like our human brains are black boxes. Like we don't know how our brains operate and what is actually going through our own mind even. But it doesn't mean that we cannot trust our own prediction or our own kind of thinking outputs, right? But still, given that our AI models are still in the early phase of development, obviously we need to put in a lot of safety guardrail to both validate what the model is saying, but then also figure out if the model itself has certain biases, right? When we train our model, again, we rely on a lot of data. What if the data that we put into the model actually has certain biases? A simple example is that if we have trained a model only based on San Francisco driving behavior, and then the model is probably going to freak out when it comes to LA, right? Just like I did. So we, again, need to collect a lot of data. We need to build very vast simulation environment for us to actually check out the diversity. Do we have enough diversity? Are we introducing biases into our model training? We need to do a very good design in our verification and validation process to make sure that we can check all the different corner cases and then whatnot.
Awesome.
And, yeah. All right.
I was going to ask a quick question on that is like when we take a look at some of the use cases, right? You mentioned some of the robotaxi companies are leading the charge in urban mobility. Yeah. Autonomous trucks promise to revolutionize logistics and supply chains in long-haul trucking. AVs are being developed for efficient contactless delivery in last-mile delivery, as well as personal autonomous vehicles in the future of private car ownership may look very different. So there are various potential applications if we look at the future. Which applications are you most excited about, and where is Nvidia focusing its efforts and why? Yeah, so for me personally, I have 3 kids, school-age kids. My top pain is driving them around every day. Right? Like, oh my God. I don't know how many hours like an average parent needs to spend on just like shuttling kids around. So for me, it's not necessarily robotaxi, but just like short distance, you can call it last mile with kids, shuttling kids. But joke aside, a lot of these different applications, obviously, like the technology, I think actually has the technology to enable different use cases actually have a lot of similarities, right? Like, so if you think about robotaxi, it's about handling dense urban traffic in urban centers mostly, or maybe residential areas. Long-haul trucking is about very stable, long-distance highway driving mostly, right? For NVIDIA's mission is about being an enabler. NVIDIA as a company obviously has an ecosystem or supporting the entire ecosystem of AV development. We have chips that are providing the hardware solution or the hardware brain these cars use. We also have Drive OS, which is an operating system to connect all the different software components. And then we also have the AV technology or the software stack on top of it, which acts as the brain to give commands to the cars on when to stop, when to speed up, and so on. So. Interesting. You mentioned NVIDIA's mission is to be an enabler. So how do you see the market for personal autonomous vehicles evolving? In terms of like different levels of all the use cases, what are some of the unique challenges that different use cases present?
Well, I think, again, I will go back to what I stated earlier. I think the biggest challenge across different use cases is always the same, which is safety. Like, how can you ensure the self-driving car itself is safe? But then when we actually see, let's say, more widespread adoption of AV technology, safety becomes more tricky because these AV cars need to interact smoothly with human drivers, right? We're going to have a mixed environment where humans somehow need to interpret the intention of self-driving cars and vice versa, right? For certain, let's say, if I break the adoption into consumer market or robotaxi versus logistics. Logistics, like I mentioned, is mostly very long distance highway driving, right? And you got to solve problems. In addition to enabling self-driving, you got to solve the problems like how do you add fuel if there's no car? No person in the truck, right? Like how do you deal with the other logistics problem of like supplying these trucks and so on. And for urban centers and passenger cars, robotaxi and the autopilot in your own car. Usually, there's a mixture of self-driving technology versus humans, right? Especially for technology that is used in your own personal car. There's a problem of like when to actually trust the AV technology to make the decision and when you actually want to take over. And that issue is always very tricky.
Awesome. We've got a couple of more questions and then we'll open it up to audience.
Right.
When we talk about the future vision and leadership, looking ahead, how is Nvidia preparing for potential disruptions in the automotive industry?
Wow, okay. So first of all, I would say disruptions are really good. Disruptions, I equate that to the word innovation. That means something new is coming up, right? And innovations are always good because they are the force pushing us forward, right? And Nvidia obviously is a very large company. The advantage that Nvidia has is that we have a lot of good people, a lot of capital, so we can actually invest into the right areas. And at the same time, we work very intensely with a lot of partners across the board. Obviously we have very large customers, enterprise customers, but Nvidia also work very closely with a lot of startups and investing a lot of startups as well, right? So as a company, we want to be constantly challenged, and we want to work with new players and be part of the innovation, in whichever way we can.
Good.
Yeah.
This is our last zoom out question before we jump into audience. Fast forward 10 to 15 years from now, give us what the future of transportation should look like and is likely to look like. Who will be the key players? How will our lives change as users and all of that?
Flying cars. So first of all, I will stop driving my kids. They will be old enough too. But anyhow, I hope they don't need to drive their kids. Future of transportation. I think, first of all, I really wish for a future where, being on the road is not a burden. Just like, the evolution of smartphones, right? Like phone used to be only used for making calls. Now, any phone that we have in our pocket is a companion to us, right? We still have the need to travel, but I hope that travel experience is something that we actually enjoy and enables us to either entertain ourselves or relax or work. But obviously, again, this is very much gated by how safe we can make the technology to be. And then very similarly, in the logistic industry, I hope that we can actually remove at least the dependency on humans for a lot of these transportation of goods, because again, it should be a service rather than a burden to our society. And then actually maybe one last comment. This is not necessarily something that people talk about a lot, but if we really fast forward 10 years from now, assuming that we have very good adoption of AV technology, I actually anticipate there are going to be some changes in our infrastructure as well. Some of you probably have heard this concept of smart transportation or smart infrastructure, which has been, I would say, discussed for almost 20 years, but it really has not taken off due to various constraints that we have. But in the future, if we actually do have wide adoption of smart cars with self-driving technology, I actually anticipate a lot of the infrastructure, physical infrastructure, can and should be updated to actually, let's say, integrate better with the evolution of cars as well.
Awesome. We'll now open the floor for audience question. Once again, slido.com, the code is Easton2. And as I'm going through some of the questions, we have a lot of questions here. There have been some dilemmas about trolley problems in AV that have evolved over the past few years. Do you foresee a change in the built environments when we talk about roads, urban planning to accommodate AV technologies as we see a wider adoption?
Well, actually, I just addressed that question a little bit, but I can expand more. So again, my opinion is yes, it's only a matter of time and then it very much depends on how widespread the AV technology will be for either both, say, robotaxi that are operated by companies or personal cars. And in fact, I have seen some pilot AV zones being set up, at least in China, in quite a few cities, where the city government would actually set out a particular portion of the city to say, hey, we're going to actually change regulations to, number one, encourage faster adoption of AV technology, but then we'll also run some experiment in building up smart infrastructure where the traffic lights, for instance, can actually interact with the smart cars as well. So it's happening. Yeah.
Interesting. And when we talk about different implementations of the technology in AVs, some companies are going with a pure vision approach. Some companies are implementing LiDARs into their AVs, and there are various other technologies.
Yeah.
Any insights on that?
Well, I used to get this question a lot, like 5-7 years ago. It's interesting to see this question popping up again. So I bet that person actually has at least looked into AV quite a bit, right? Because there are indeed two camps. Tesla being one camp saying like never ever I'm gonna have LiDAR, and then many other companies says like why not, right? Like it makes your car safer. I really don't have a strong opinion one way or another. I think we should do the safest thing for the cars. Oftentimes concerns over LiDAR is over cost, because as of today, LiDARs designed for cars are expensive to make. But imagine it only costs, I don't know, $1. Like you'll probably have like so many LiDARs around your cars, right? Like why not, right? It's really not about, at least I don't have any, opinion against using any type of sensor, as long as we can actually use them safely and then deploy them at a reasonable cost.
Interesting. And do you have any insights on the timeline for the full-scale implementation, like the full takeover in terms of trucks and buses, supply chain and logistics?
It's very hard to predict the future. I think the rollout of the technology will be gradual. Again, very much gated by maybe primarily two factors, right? One is safety, and the other one is regulatory environment. I do know there are certain, like I mentioned, particularly in Asian cities, I have seen more rapid adoption of AV technology through these experimental zones, including city shuttles, right? So as of today, probably these zones are still small. Actually in US, same thing, right? Like we see robotaxi operating kind of in the limited urban cores, but every company has a roadmap to expand, right? So on one hand, like the timeline is now, we can all be users of this technology today, but the challenge remains in terms of both safety, but then also have the AV technology to be able to adopt to a lot of harsh environment, right? It's easier to drive on roads that are very well maintained, much harder to drive on roads that are poorly painted with a lot of potholes, for instance, in rural areas. And then weather is another big challenge as well. So I think there's going to be a rollout, but it's difficult to say like when exactly what we'll see. Yeah.
Interesting. There's a lot of folks that are talking about AVs for consumer use case. Curious to hear your thoughts on AV for industrial applications and how it impacts the way economy is mobilized.
Yeah, so as I mentioned, like there are some early adoption of AV in very specialized industrial setting, right? I cited the example of the autonomous ports in China. I think there are at least 2 cities or 2 ports that are that have implemented this and is actually operational. So the entire port has no people driving these trolleys around. Long haul trucking or last mile trucking is something that is more challenging because it's not only about just the AV technology, but as I mentioned, you gotta solve the other logistics piece to support AV technology as well. I have also seen examples of AV technology being used in kind of a more limited industrial. They're like, I guess they're not necessarily parking, but industrial park where you again have to do transportation of goods from maybe one lot to another. Over time, I think things as technology becomes more mature, I think we're going to see more and more of these industrial applications. And in fact, in these more controlled environment, the problems actually tend to be easier compared to crazy driving on public roads. So if we actually can find if companies can find the right niche market, this can actually take out faster and then roll out faster compared to rolling out to consumer market.
Interesting. So what's the tipping point for users or consumers like us to feel safe in AVs at scale? Will it be an Intel Inside version of AV software or a hardware? Any insights on that?
Well, I think really for people to feel safe, you should get into the car, whether or not it's a robotaxi or your own car, right? Actually, maybe let me talk about that separately because it's different. Like for robotaxi, it requires the technology to be mature enough that it can handle any situation in its designed ODD, right? Because if the car actually gets stuck because of whatever reason, the passenger is stuck as well, right? So the bar is a lot higher. But for the AV technology to be applied to the passenger cars, many cars these days have, including Tesla, obviously, being a front runner, one of the front runners in this space. There is always what's called a backup solution, which is yourself, right? So in that sense, the technology rollout for consumer cars can be a lot easier because it doesn't have to solve full self-driving problem from the get-go. In fact, by deploying these, and then the technical term is called ADAS, Advanced Driver Assistant System. So basically, it's a chauffeur assisting you, right? By applying this ADAS technology to large number of consumer cars, AV technology companies can have the ability to learn from what actually works well and then what doesn't work well, and then build that feedback loop to enhance both the performance as well as the safety aspect of the tech.
Interesting. And when we talk about feeling safe for consumers, any insights about innovation in AVs that could impact accessibility or make it better for disabled people or mobility compromised individuals?
Yeah, I think that really falls into the category of you really need to have a technology that is 100% reliable, right? Because if someone is not able to drive the car or very challenging for the person to drive the car, then we need to provide full autonomy, right? And that's very similar to kind of the robotaxi application that we see today.
Awesome. Yeah. And looking ahead, as you mentioned, 15, 20 years from now, how can AI contribute to different elements like traffic signaling, for example? Will we see a future where AVs will integrate with the traffic signaling system and other traffic components? Oh,
okay, that's interesting. So maybe let me take one step back and answer this question in a more generic way, right? So the question is about smart infrastructure, and I think the answer is yes. I very much like to see that. And then, like I mentioned, some cities are experimenting with this kind of integration already or interaction as well. But I'll maybe give example for a few other scenarios, right? The interaction between cars and infrastructure is called V2X. Vehicle to infrastructure. And then there's another type of interaction that is called V2V, which is vehicle to vehicle, right? And vehicle to e-vehicle, you can imagine like for us to, if we're able to do very tight coordination between the vehicles, we can actually reduce a lot of traffic jam on both surface streets and on highways, right? Because as you know, not only the traffic jam is caused by accidents, but oftentimes just humans, if you do a sharp brake, then you suddenly cause, all the cars behind you to do brakes, and then suddenly you create a traffic jam out of nowhere, right? And then by optimizing the coordination between the cars, we can actually pack more cars and increase the volume of the cars that we can have without actually adding more roads. And then one more example I'll cite is that everyone likes chatbots, right? And then now you imagine not only AI can help you drive the car better, but it can be an integral part of this whole driving experience in your car, where you have an AI assistant next to you inside your car, helping you with all aspect of your time spent in the car. So hopefully it will be a fun experience as well.
Awesome. So now we're going to close with audience questions, and we'll be doing a couple of so what's, or the key takeaways for today's panel. And I'm a student, you have a PhD, so I expect a grade at the end of this. So the last couple of years have been a bullet train, but looking ahead, we've got a supersonic jet in terms of where AI and autonomous vehicles are going to take us in terms of, let's say, 5-10 years from now, which means big changes are coming from the society, for the society, and this technology is going to affect all the different sectors across the world. Second point is that NVIDIA's mission is to be an enabler. There are a variety of enablers that allow this change to happen, certainly quantity, but as you mentioned, more to the quality side, that's really the frontier here. And this isn't just about predicting with 100% accuracy, but this is a game of probabilities. So there might be an education element in terms of educating public in terms of safety, what about autonomous vehicles can do, and what certainty we should have as we listen to recommendations. And of course, job displacement. It sounds like general advice is to get comfortable with AVs now, start to learn, start to use them, and if so, you can speak the language, walk the talk, maybe have a nice conversation with your car, AV, as you walk out of UCLA today. How was that? Any upgrades?
I've loved that.
Awesome.
Yeah, I mean, it's, I think what you said earlier, embrace the technology is 100% spot on, right? I myself need to adapt as well. And in fact, having worked in the AV technology field for a long time at this point, I've seen this revolution where we have to kind of transition or pivot from the traditional way of building the technology, or the heuristic-based or rule-based modeling, to the foundational model. I'm observing the revolution myself, and it's very exciting.
Awesome. Before we hand it back to Professor Kramer-Wei, let me just say thank you for all the insights, all the way from technology innovations to the future of autonomous vehicles. Congratulations on your career and what your colleagues are doing at NVIDIA. Everyone, please join me in thanking Wei Luo.
Yeah, thank you. Thanks.